Hey, thanks for having me today. Yes, I'm David Haylock, mechanical engineer, GSAP for Cosgroves, and I'm going to talk to you today about this waste management consolidation project. To start off, I'll just do a bit of brief information about myself and Cosgrove. So I've been working in the industry for about 10 years with a focus on sustainability. I've always tried to improve what we can do with the projects I've been involved in. Cosgroves is a nationwide firm. We've got 5 offices around the country. Our core business is building services and civil engineering. We also pride ourselves on sustainability designs and compliance. And we've recently launched a specific sustainability offering for our clients. The Waste Management Consolidation Project is a large industrial project bringing together several of Waste Management's sites into one key location. The site covers 5.5 hectares and contains large workshops for truck maintenance, bin maintenance, washing, painting, EV truck fit out. It's got truck parking, bin storage and their head office all on one site. So there's quite a lot going on. The project has 2 key clients, the developer, Stride Property, and Waste Management, the long-term tenant. To have a project like this, you need a client that will embrace the journey and commit to doing something that's better than the norm. At the start of the project, there was a clear directive that this project would do better. Waste Management's key values are safety, challenges, care, and community. All of these are encompassed in the project. However, there are key ones for today are care and responsibility, safeguarding the environment to ensure we all have a clean and healthy future, and the commitment to community. These values drove a client to develop something better for themselves and for those who will use it. So the consolidation site is located in southeast Auckland, bordered by 2 major roads and a park. The site's away from most major public transport links, meaning that the site has a large complement of car parking for its staff. Before the project, nobody cycled to work to any of their previous sites. However, we managed to get a 34 cycle park undercover and secure for bikes. And the manager who was running the project at the time, once it was open, started cycling to work from the Waiheke ferry at Half Moon Bay. And we're kind of hoping that a few more have taken up the case since. Cycling as a form of transport has also changed quite a lot during the project. At the start of 2017, electric bikes were a fairly minor part of the commuting infrastructure. However, by the time the project was finished in 2020, electric bikes were becoming a lot more prevalent, and we made sure we allowed for that with charging. The project team was engaged in the project with minimal design having taken place. Bulk and location had been undertaken, but nothing was locked in. So a series of workshops was undertaken with 20 or more people in them, where everything was run through and discussed and considered. These workshops included Waste Management, Stride, the architects, all the engineers, GSAP and the PM. This integrated design approach meant the sustainability of the site and buildings was included in the design from the very beginning. From these workshops, the layout of the site, features, size, requirements, all major design decisions were made with the whole team present. Safety is a key feature for waste management, and the site layout had safety at the forefront. There's a clear split between the left and the right of the site. The left is the public space where cars can come in and park. Everyone to site enters through the main door into the office and hub space. This space then links to the workshops, industrial space, as well as the office. Trucks can then leave site, and once they return, everyone comes back through the same location. This layout and split means that people movements on site are tightly controlled and you can't inadvertently end up in the wrong location and put yourself in harm's way. It also means that everyone on site has access to the key features that improve the health and well-being of the occupants, such as the staff amenities, the catered hub space, and the office space. It was important to try and get some soft landscaping onto the site. There was a drive to maximise the hard stand area of the site for industrial use, but there was also possibility to get some grassed and planted areas. The landscape space on the site helps improve rainwater runoff quality and reduce the peak flows. It also improves the overall look and feel of the site for the occupants. A lot of the green spaces acted as swales throughout the car park, and the planting was done in natives. So we had the basic layout of the site, but now what? What's important for this site? Water. With the large impermeable area, there was an increase in the stormwater runoff, so we had to attenuate this in some way. This was achieved by increasing the size of the stormwater pipes to include detention, and then slowing down the flow out of these pipes with orifice plates, as well as using swales in the car park and an extra detention tank in the rainwater system. Another aspect of the runoff is the quality of this water. Although the site doesn't see much waste from the trucks, it does deal with a lot of residual, and we didn't want this to wash down the drain into the creeks nearby. This was improved by using 2 large jellyfish filters, which take the high flow of stormwater and pass it through a filter membrane, which removes 80% of total suspended solids from these hard stand areas. Energy. Waste Management already had a large fleet of electric vehicles and plans for more. So 40 car chargers and 10 truck chargers were installed, with infrastructure for up to 100 light vehicles and 50 truck chargers in place. These chargers have sophisticated load management systems to monitor the loads at the transformer and get the most out of the available energy. Materials. With such a large site, there was a large requirement for the likes of PVC pipe. Where PVC was used on site, it was best practice PVC, but where possible, alternatives were used. The rainwater collection pipes were run in polyethylene, which had a durability advantage, and the large stormwater pipes and civil infrastructure were run in concrete. Now to focus on the office building. This was designed with a central core that provides connection to the entire office space. It was also how fresh air gets in and out of the building from the plant deck and the roof. The air comes in from the plant deck and is distributed throughout the building, depending on higher levels of CO2. It is then returned at high level back to the plant deck, where the energy and moisture is exchanged with the incoming air before it is exhausted. This gives the most efficient supply air system for the building, reducing the conditioning loads as well as the fan power, as the building only receives what it needs and is not run unnecessarily. The core also allows for light penetration well into the building, providing diffuse southern light throughout. During the design process, it was decided that the office would be predominantly orientated in a southerly direction, with the largest facade and glazing space pointing south. The services core of the building is pushed to the north, and a large concrete wall to minimise the glazing on the north facade. The office space is aligned along the southern facade as much as possible to allow the best light to work to, and to keep the views open for the staff without the need for blinds to be down all the time. The large floor-to-ceiling windows would likely overheat the space if placed on the northern facade, but on the south, these windows provide an open and spacious view. The north, east and west sides of the buildings also have large overhangs to reduce unwanted solar gain and glare into the building. These design features also reduce the overall size of the mechanical systems required for the building. A catalyst for this project was to reduce the barriers between waste management staff. With so many different teams on site, it was important they all felt they had access to the top quality facilities, not just the office workers. The hub and amenities space for this was key for this. The amenities block provides large clean-up, change and shower facilities for all staff and acts as a buffer between the industrial operations and the office. Once through the amenities, you enter a double-height hub space which provides a catered cafe, kitchen facilities for staff and a central communal space. With 300 plus staff using the site, the space allows for all occupants to meet and work together. Materials play a key role in the sustainability of a project. Initially, it's good to just consider the 3 R's: reduce, reuse, and recycle, and how these can best be applied. Reduce. By having minimal finishes on materials such as the exposed particle board, polished concrete, reduced ceilings, the use of materials was reduced in the office spaces and the industrial workshops. Reuse. The concrete from the demolition of the existing building was crushed on site and reused as hard fill, which reduced the imported fill greatly and reduced waste to landfill. Recycle. The use of materials with a high proportion of recycled content, such as rubber flooring, gyp board, and insulation, were chosen to reduce the impact of these products. Timber is a great product, as has been well discussed today, but it is important to ensure that it is grown, milled, and processed in a sustainable manner. And for this project, we used just over 95% FSC compliant timber. Lowering VOCs and surface finishes is also really important for the health of the occupants of a building, especially when new, and the majority of the finishes were chosen to be low VOC, except some of the floor painting in the industrial spaces, which required highly durable paints. The exposed concrete also helps with temperature and comfort of the space. All of the exposed concrete is isolated from the outside, so provides great thermal mass to smooth out temperature fluctuations due to solar gain and high people densities. With regards to waste diversion, we had a 99% diversion from landfill during demolition and 76% during construction. Construction waste is a big focus for waste management, and we hope to see projects improving on this construction waste diversion in the future. The office building has an efficient facade and efficient systems, but without the monitoring, these systems can run out of design parameters and use a lot more energy than planned. So we've installed a comprehensive energy monitoring system for the whole site. This keeps track of all electricity uses and compares them so that errors in operation can be picked up and rectified. The goal for the office is to run at 75 kilowatt hours per metre squared per year, and is tracking towards the target. There are periods when it operates a lot more efficiently than this, and it would be nice to see if we can reduce it over time. The site is also set up for solar panels, but unfortunately these didn't make the construction. However, there is a possibility to add them if the business decides to. Our analysis during design had the payback at about 8 years for a 200 kilowatt system on site. The EV chargers are all interconnected as part of the energy management system and provide load management as I described earlier. This is important as the chargers would easily overload the electrical infrastructure if they were allowed to charge all at full capacity. For future additions, there is allowance for dedicated transformers on site for these large truck chargers. On site, there is also a workshop to fit out rubbish trucks with electric motors and batteries. These systems come from Europe and are fitted into standard truck chassis on site in that workshop pictured. These trucks and cars help waste management reduce their overall CO2 emissions. As I already discussed, stormwater on site was a key consideration, but so is recycled water. The site has 150,000 litres of rainwater storage for reuse. This is collected from all the roofs on site. The majority of this water is used in washing bins and washing trucks. A large proportion is also used for flushing toilets. The graphs show the daily water use, the green being the rainwater, and can compare it month on month. The truck wash also has its own recycling water system. For each truck wash, it uses 1,000 litres per wash, and 700 of this is recycled and 300 discharged to be replaced. The rainwater tanks pictured are the ones used for these industrial uses. They are plumbed to the downpipes with sealed PE pipes and can take rainwater flows of up to 150 litres a second. On the pumping side, we have a large sand filter to ensure particulates don't go down the line, and an automatic water changeover in place for when the tanks run low and the mains water needs to take its place until it rains again. The site has been using up to 30 cubic metres of rainwater a day. So I've gone through this whole presentation and I haven't mentioned Green Star yet. I wanted to focus on the attributes of the site first, not just the compliance. But Green Star is a great tool to ensure that projects actually do what they say they will. And this project is no different. Without the goal of Green Star compliance, a lot of these aspects could have been cut off the bottom of the line. And the extra cost and the impact of these cuts wouldn't have been fully understood without the tool. We started this project using the Australian Design and As-Built tool as a test case for the New Zealand Green Building Council while they developed the New Zealand tool. And during design, we weren't exactly sure which tool we would end up being assessed under. The Green Building Council provided guidance as we went along about the changes they would make between the tools, but it wasn't until the building was nearly complete that the Green Building Council released their latest Design and As-Built tool, which we are currently being assessed under. Early on, we decided to assess the entire site rather than just the office building. And this has proved challenging, but I'm happy we did it this way. It means that the whole site gets the advantages of meeting compliance, not just the office space. Therefore, we have been able to improve the workplace and sustainability for everyone on site. The challenges that we're faced by doing this relate to the different uses on site. We have different areas, energy profiles, water profiles, lighting profiles, and the list goes on and on. There's nothing in our submission that is standard. It's quite comprehensive. It's also a fully integrated fit-out, so there was no base build done for this project. It was tenant-focused from the very start. One of my main regrets would be that we didn't do a design submission for this project. I think due to the development of the tool as we were going, it would have been really beneficial for the project as a whole to carry out a design submission and would have made the built submission a lot easier. We are currently finishing off our second submission. Our first had quite a few comments and credits that needed clarifying, but we're confident that we can meet these requirements. Our goal is for a 5-star built rating. So thank you for listening today. I hope you got something out of this. If I have one thing I'd like you to take away, it would be this. Don't be afraid to push the envelope and move towards more sustainable projects in all forms. It's relatively easy to make an office building sustainable, but industrial, supermarkets, hospitals, there are massive gains to be made in those areas. Thank you.
Thank Thank you, David. Just time for one quick question. This is a nice design for operational carbon, but the structure was concrete and steel. Why was embodied carbon not considered?
Well, we can't consider everything, unfortunately. As I was saying, the LCA tool was quite new at the stage, and it was considered to be a hard thing to go down. It's a massive site with a lot of concrete, and the challenges of trying to do this with a low embodied carbon would have been massive. So you pick your battles.
Please put your hands together for David Haylock.